Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, we're going to buck the trend and get started, and then I'm sure people will flow in with their muffin, coffee, whatever. I want to welcome you to this session on unlocking the potential of digital home infrastructure. So this is like an airplane. If you're not in the right place, you should hop up now, run out of the room. But hopefully you're all here for a really fun session that we're going to talk about digital home infrastructure. We have a really fun set of speakers to talk about technical challenges and research approaches for novel sensing in homes. Our goal is to make this fun and interactive. So basically, each speaker is only going to talk for about 10 minutes. Then they'll have 5 minutes for questions. And we hope that leaves us actually half of the session for you guys to say, well, these are the challenges I face, or these are the things that I think you should all be doing, and all of those things. So while they're all talking, yes, do your email. Well, hopefully not. But think about the questions that you have, and we'll have them up as panelists at the end. So fun and interactive means, you guys get to make it. It's as fun as you guys make it, although we have lots of fun and provocative questions as well. So with that, I'm going to introduce our first speaker, Dr. George Damaris. He's a professor at the School of Nursing and Biomedical and Health Informatics at the University of Washington. His research interests include the design and evaluation of home-based technology for older adults, patients with chronic conditions and disabilities. And I've been present when he's given many very inspirational talks about the work that he and his group does. So he's currently the chair of the International Medical Informatics Association Working Group on Smart Homes and Ambient Assisted Living. Hopefully there's an acronym for that somewhere. Okay, good. And he received his PhD from the University of Minnesota. So please.
Thank you. I hope you can all hear me okay. So as AJ mentioned, my name is George Damaris, and I'm from the University of Washington. And I'm in the School of Medicine with a joint appointment in the School of Nursing. So this would be a good time to disclose that I don't have a computer science or engineering background. But hopefully some of the work we do in biomedical and health informatics has specific implications for this conference. And today I'm going to be talking about some of our work looking specifically at smart homes to support independent aging. And we define smart homes in our work very broadly as residences that are equipped with technology to enhance safety and well-being of people at home and use the technology to monitor their health condition. And what we're doing in this work, which is somewhat different from traditional home monitoring, is that we're looking at technologies that are not necessarily operated by the users, but instead become an unobtrusive part of the residential infrastructure, so that hopefully people can be monitored in their home without having to change their daily activities or have to learn to operate hardware or software. So the work is informed basically by the fact that older adults have different healthcare needs, and they primarily want to stay at the residence of their choice for as long as possible, rather than have to be transferred to different levels of care and different settings of care every time their healthcare needs change. At the same time, older adults have various needs, and not everybody has the same needs or challenges, and we're looking at ways to support people who are experiencing perhaps different levels of chronic disease or decline at varying rates in areas of well-being. And several interventions have looked at just one area of older adults' wellness, but what is really needed in order to promote aging in place is looking at a holistic approach to wellness. And here's where smart homes may potentially have a role to play as we look at ways to deliver interventions that cover multiple aspects of wellness. Our work is informed by the theoretical framework of wellness by Halbert Dunn, which basically dictates that wellness is a complex concept that has many underlying constructs: the physiological, and functional, the mental or cognitive aspect of wellness, the spiritual and the social. And so as we try to monitor one's well-being, there's a complex set of parameters that one could assess. Some of those parameters are already being assessed, but perhaps not continuously. For example, when older adults go to their healthcare provider, they may have their vital signs assessed, or they may fill out several surveys trying to assess quality of life or spirituality, social isolation, depression, and so forth. What we try to do is see how commercially available sensors could perhaps become part of a smart home project to assess some of those aspects of wellness. So today I'll give you some brief information about an actual ongoing demonstration project we have that is taking place in an independent retirement community here in Seattle. For that, we have been partnering with that community to recruit residents who want to be part of this study. And we're recruiting people who are 62 years or older, and that's because that's the criterion for the facility, and who are residents of our partnering community, who are independent in activities of daily living and are able to provide informed consent. As I mentioned, we're using sensors, and many of them are just commercially available. We use stove sensors to detect when somebody is preparing a meal, and motion sensors throughout the home. One of the concepts we're trying to capture here is mobility, but mobility defined more broadly, not just in terms of activity levels, but actually how one increases their life space and how active they are within their home, but even outside the home, as they perhaps interact with the community. So we've placed the sensors throughout the residences of the individual participants and are trying to look at how we can integrate data to make inferences about patterns of activities of daily living, as well as overall activity. And what we do there is trying to look at a case by case, trying to see whether the amount of activity in the home can in many cases explain the occurrence of adverse events. So here is an example of a resident who did experience a fall and a hospitalization. So after we know the event occurred, we go back to our sensor data and look at the activity data to see, is there any pattern in changes prior to the event that could perhaps ultimately help us predict such an event, and how does the overall pattern of activity levels change over time. Our goal with, in general, this type of work is really to look at smart home and ambient assisted living applications, which is what this acronym stands for, and see how we can capture the data about people's activities of daily living. But obviously that alone is not sufficient. Getting more data doesn't necessarily mean that we would have the human resources for anybody to look at them. As a matter of fact, in many focus groups we've done, clinical providers are concerned about new data that they may be held accountable for, but they would not have the time to process them. So we have to come up with the data analysis techniques, whether those are pattern recognition, data mining, behavior reasoning, that will help us extract the information that is important, and in a way that can, with high accuracy, detect the emergencies or show certain trends that can help us act upon this information and potentially prevent these emergencies. Our ultimate goal in our group is to get this information then into personal health records and find ways to visualize the information so that it doesn't become burdensome, but instead becomes helpful, not just to healthcare providers, but to older adults and their families themselves. So one of the goals in our work is to use the information to perhaps empower older adults to become more active in the decision-making process. The information that may come from this type of sensor data or other types of smart home applications can really be used for education, to allow people to perhaps implement some behavior changes if it is important to maintain independence, or we can inform tailored interventions for the specific needs of one individual. That has been the case in some of our examples with urinary tract infection, where you can see sleep quality being interrupted by bathroom visits, but also decisions that inform transitions in care, where many times older adults and their loved ones have to make those difficult decisions without having enough or objective data. When we think about smart homes, especially with older adults, the concern obviously is always that of privacy and whether people may accept technologies that are actually monitoring their daily activities in all places within their residence. In our work, we've used the Belotti and Sellen framework for privacy, basically trying to assess whether people's concerns about the privacy features change when they receive feedback about the different dimensions of the system and when they have control over those different dimensions. And obviously people want to not only know why they're being monitored, but be able to determine when and how they're monitored and who gets to share the data that's being captured about them. We have also been looking at some qualitative work to better understand obtrusiveness. In many cases in smart home literature, we talk about how those systems are non-obtrusive because the user does not have to operate them. But obtrusiveness is not just whether it's easy or difficult to use. It's much more broad, and we define it in our theoretical framework as basically the summary evaluation by the user based on the attributes and effects of the technology that are perceived by them as undesirable and physically and/or psychologically prominent. And those can include not just the issue of the physical dimension of the technology or whether it's easy to use, but the concerns they may have about privacy, the human interaction, what it does in terms of their own definition of self, potential stigma, whether it interferes with daily activities, and concerns that people have about the long-term sustainability of such systems. So, in our work, we've done so far in this project that I mentioned in Seattle, 25 subjects, and we have had single household people, meaning people who live alone, which obviously makes the capturing of the data from the census much easier to interpret. And some of the challenges do occur when you actually have multi-person households. Furthermore, we have people who have the cognitive capacity to provide informed consent to participate in the study. Another challenge occurs when some of these technologies are used for people with dementia or cognitive limitations where somebody else is making the decision on their behalf. There's, in addition to that, many other ethical challenges in terms of monitoring visitors, issues of not just the technical feasibility of smart homes, but also some of the more broad policy challenges, reimbursement, who looks at the data, where are the data stored, and who should be informing clinical interventions based on the data. And obviously there's a concern that perhaps by using those types of technologies, we may be promoting dependency rather than supporting dependence, which is the ultimate goal of such smart home technologies. In our focus groups, residents welcome the technology and have very little concerns about privacy, but they do worry that this automation may actually lead to a reduction of social contacts, that people may be less inclined to visit in person because they can rely on the information that comes to them electronically, and that they therefore may actually see their community nurse less often, and similarly family members may be logging in remotely to see the overall wellness data, but not actually checking on their loved ones. There's the concern, therefore, that this may substitute personal forms of care and support and may lead to over-reliance on automation. So it's a challenge for designers, evaluators, and healthcare providers to find the balance between the accurate data that are objective and capture details about activities of daily living and the need for not only privacy, but more personal contact with loved ones and healthcare providers. And so with that, I'd be happy to answer any questions you have. I put two links here. One is for our project, the Health E-project, which includes this pilot project I just mentioned. And then there's also the link for our smart homes and ambient assisted living work group that AJ mentioned earlier. Thank you.
Okay, so we have microphone runners. So can someone run in about 5 minutes for questions now? And if you don't get your burning question answered now, there'll be the panel discussion at the end.
Hi, Lily Coney with EPIC. I had a couple of questions. You use terms that people who are in usability, accessibility, privacy, are you going to use, I think it would be helpful if you use terms that crossed across disciplines. So when they're looking at the research or hearing about what you're doing, they'll know what they're looking for within the research for their particular communities. Specifically on the issue of privacy of health data, people would be in their homes and data would be transmitted over internet. Are you looking at aspects of securing that data and then as well as having it available to the individual who the data is about or to a designated person? All the nitty privacy issues, how are you dealing with those?
Yes, so in this study, in the demonstration project, we are capturing the data in our own server, and there is access granted to the participants who are the older adults themselves, as well as a designated family member or healthcare provider. This is the person that the older adult identifies during the informed consent process. And this is obviously a great concern in terms of privacy and how the data are stored, but more so also the perceptions that older adults have about who may have access to their data.
But the security issues are the data in transit and at rest from the collection point to the end point where it's being stored. And then the storage issue is how long will data be stored? I'm presuming if it's health data, it may be stored over a long period of time. So how do you deal with that internally for securing the data, and who has access controls, log files that record what's happening, and then have internal protocols for dealing with?
Yeah, so the sensor data are stripped of identifiers. There's a separate system for the sensor data. So they are not actually health data. This is just a huge data set of sensor firings. And the linkage to the individual participants is not on the same server. So the actual information of the individual participants is linked with a de-identified data which is stored in another server. The data, the sensor data are stripped of identifiers before they get transmitted on the server.
I can just speak up.
Well, it's for the recording.
Oh, okay, yeah, fair enough.
You have a loud voice and we can all hear you. So it's friends online.
Thanks. I saw a label by a camera that said privacy preserving camera. I don't know if you, I was just curious, what is a privacy preserving camera?
Oh, so with privacy preserving camera, which was another study, we've looked at ways where the actual information gets extracted so that all you end up storing is silhouette extracted images, not the actual person.
Okay, thank you.
And the reason for doing that is that in some earlier pilot work we did, people would be open to the idea of even visual sensors or cameras in their living room if they were to preserve their privacy, as they called it, by extracting the identifiers, by creating silhouette images.
Okay, quick final question. Great, why don't we do that while Ratul sets up?
Okay.
Can you explain to me the process that you went through that determined that silhouettes of me in my living room are made private and de-identifiable by lowering the image? I mean, if it's me in my living room, and most elder people live alone, how does that provide a meaningful increase in privacy? I mean, how much was it the change in the data, and how much was it that you put a label on the camera?
So just to clarify, because the question was about an image there, in this project we're not using cameras and we're not extracting silhouettes. It's basically just about the motion sensors. In the previous pilot where we tried to look at ways to extract images or to extract silhouettes, the concern was about the images that are being stored. And so the silhouette, which is not identifying the individual, but rather shows a pixelated silhouette of somebody sitting versus standing, was what people found to be less obtrusive, meaning that they were being able to consent to have that information stored about themselves. But this is not we're not using that feature in the pilot that we're using the motion sensors in the independent retirement community. Thank you.
Great, let's thank George. Thank you, George. and he'll be back for the panel at the end, so you can save your extra questions for George. So now I have the privilege of introducing our second speaker, Ratul Mahajan. He is a researcher at Microsoft Research, and we work closely together, so he's probably dreading this introduction, but I'm going to keep it on the up and up. His research interests include all aspects of network systems. He also recently won the ACM SIGCOMM Rising Star Award, and he received his PhD from the University of Washington.
Thank you. Thanks, AJ. So let's see. So certain things I've gotten screwed up with the template, so I hope the slides look okay. But anyway, so what I'm here to talk about today is some work that AJ, and a bunch of other colleagues have been doing over the last 2 or 3 years. And the goal of the work is we are asking ourselves the questions like, what does it take to make digital technologies in the home more broadly used and developed against by researchers, by developers, and used by people? So, and these are some of the other people who've contributed heavily to the project in addition to AJ and me, and Jay and Frank and Erjman, Sharad, Colin, Bangshin, and Stefan. Apart from Colin, who's now at IBM, all of us work at Microsoft Research here. So essentially the starting observation, like I said, is basically the following observation, that connected devices for the home are becoming incredibly cheap. So they are inexpensive. Each of these devices that you see, from a camera to a motion sensor to a door window sensor, thermostat, a panel, can be bought anywhere between $30 to $100. Each of these have like a network card, so installing them is easy. They don't need any new wires often. They use regular voltage. And the wireless standards themselves are maturing. So to us, when we look at this evolving ecosystem, we basically say, okay, it looks like the hardware ecosystem to make smart homes or other home technologies is there. Why do we not see a broader adoption or broader development of these technologies at all? So that was the beginning question we asked in there. And so AJ and I and our colleagues, to understand this question, we went to a bunch of households asking them, and these are households that are living with home automation systems, and to basically understand what they like and what do they not like about it. So our hypothesis was, if we go to people who are living with these technologies, we'll understand the pain points by which these technologies can be made. If we could relieve those pain points, these technologies could be more broadly accessible in there. So what we find is, like, for people who are living with smart homes today or home automation, they have essentially 3 pain points. One is that, they have 3 reasons why they actually like what they're living with. And things like health are not there because those are not broadly deployed, but I'm sure the kinds of technologies that George was talking about would be yet another reason for doing it. But we found for things like people really love it for convenience. So, we interviewed about 30 people, 25 of them would say, okay, it allows me to be lazy. And they all say it very, very sheepishly, actually, thinking they are the only ones who like to be lazy, but that's not the case. The other one was it's peace of mind. They can actually track where things are. Hey, did I leave my garage door open? So no worrying about what the state of the house is when you're not at home. And the other is control. They just like things to be on their fingertips. So from sitting on your couch, you can close your garage door, or you can monitor who's at the front door. And so they basically felt that because they have this home automation system and like a remote controller or a panel, they felt that they had control over the household, so to speak. So basically, I think I should say that people who are living with these technologies, overall, their reaction was very positive. But we would also ask them, hey, would you recommend this technology to your friends and family? And they'd basically say no. And so, like, why are you, like, you seem to love it. Why would you not have your friends and family enjoy the same benefits? And basically, I think when we ask them, like, why delve deeper, 2 main issues kind of stand out, basically, and these relate to manageability and extensibility of these technologies today. So manageability essentially refers to, like, a home is a multi-person household. So if you want to stop your kids from doing some things at night, or if you want your guests to access some part of the technology, let's say the printer, but not the others, let's say your taxes sitting on your shared hard drive. So doing things like that was really, really difficult in there. Similarly, access to devices was an issue. Like, no software application should be able to open your lock at night, no matter who's running it and things like that. So people found a real hard time actually keeping the home automation technologies under check. The second thing is extensibility. And extensibility refers to the fact that given that you have some amount of technology in the home, you want to buy another piece of hardware, another piece of software, does it run in your home, given existing things or not? And people found that really, really hard to judge. And this became a stumbling block because it stopped people from starting really small, as they like to, and build up according to their wishes, rather than the model that we saw happen today was you got to go all in, essentially. First decide, okay, this is what I want in the home, and then go with it, either with a professional install or buy everything together. So you make sure it kind of works together. So we ask ourselves, so like, why is this happening? So I think I'm a systems person, so I look at things in terms of like abstractions that systems provide. And our thing was that basically current systems are providing two abstractions. One is to the developers and to the users. So one abstraction is this abstraction of a network of devices. So your home as a technology piece, or the technology in the home, appears like individual devices, just like internet is a bunch of servers. The problem with that is that the network of devices management is really hard for users. Everything is an individual piece, so you got to configure it automatic. You got to configure it. You have new interfaces for everything else. At the same time, you have to individually configure access control rules, who can access what, configure users, and so forth. The second abstraction that commercial smart home technology today provides is what we call like an appliance. This is like a big monolithic system. Today, the examples are restaurant control for easy living. And it has a fixed set of tasks over a fixed set of devices. The problem here is that extensibility is really hard. So you have a closed set of things, and if some, like you as a researcher or a developer, wants to extend that, it's really hard for them to do. So essentially, I think our core hypothesis in this work is that we are going to provide a different abstraction. We are going to organize the home just like a PC. By that I mean that network devices should appear like peripherals that are directly connected to the PC. Any task over these devices, like opening door locks or media should follow you as you kind of walk around the home, are basically applications that are written in high-level APIs rather than against low-level devices. And it makes management and extensibility really easy, because adding devices should be just like adding a peripheral in there. Adding tasks should be just like installing an application. And managing network devices should be just like managing files and setting access control rules on them. So this is like a high-level view of how HomeOS works. It essentially has three pieces. The first piece is what we call the Home Hub. The Home Hub is responsible for talking to all these devices, and it provides high-level APIs to applications like dealing with security and climate that run on top of this stuff. A second piece is what we call Home Store. It's meant to simplify extensibility. So what the Home Store can do is recommend to you devices that correspond to the applications you are interested in. For instance, you really like the idea of having motion-sensitive lights, but you don't have motion sensors. The Home Store can tell you, hey, you have remotely controllable lights, get a motion sensor, and you can run this application. At the same time, it can recommend to you applications that are already compatible with the devices in the home. A final piece of HomeOS is what we call the Home Cloud. This is basically simplifying remote access to the home. It's also storing the data that's coming from the applications, so it's not sitting on that puny Home Hub box, and makes the whole thing work together in one seamless way. And because I'm going to quickly actually touch on what the architecture of Home Hub looks like, but the details are in the paper, or one of us is happy to talk to you. Essentially, Home Hub can be thought of as like 4 layers. One is like we call device discovery. The bottom-based layer is responsible for discovering devices that are in your home network. It passes that on to the functionality layer that detects the type of the device and offers high-level APIs to applications, so applications are written in high-level APIs. And as we write these things, we are allowing for extensibility right at this low-level layer as well in there. And we design primitives that are specialized to the home setting. In our interviews, we asked a lot of people what kinds of controls you want. And we have some new primitives in this layer that are specialized for the home setting. Like time, for instance, is a key parameter that does not show up in current OSs, but in home, if you want access control, time should be like a first-order thing in there. And finally, applications are using simplified abstractions, and they also come with their requirements. This is what lets Home Store do the matching of compatibility in there. So where we are right now with HomeOS is that we have a prototype that's a software module that's run in C#, so anything that has managed framework running will run here. We have support for several devices and protocols in there. And we've done in-lab evaluation, but along with that, we've also done field evaluation, by which HomeOS is running in 12 homes. And we license it out to academics for just free non-commercial use. And about 50 students across 12 institutions around the world have used HomeOS to develop research prototypes. To give you some examples of things people have done, this is a system out of MIT where people would say, how do you program your home using just tactile feedback, where you go around the home, perform actions, and link them together. By the way, I'm rushing through this, I realize, but the videos of these things are online, and so are a lot of details. This is a system that a class at UW that I taught with John here, who's sitting here, developed. These students basically, how do you control your home using Kinect, using gestures to turn the lights on and off using Home OS. This is a system from Waterloo. Raymond, who's here as well, what they do is do energy tracking for your home and detect when your consumption has gone off the roof or is abnormal. Finally, this is a system out of University of Arkansas, Nilanjan and his students developed, and which has to do with like remote monitoring of what's happening in your car, in this case, let's say a teen driver or something, for instance, and your stream will come to the home and you feel it just like a camera attached to the home setting. This is a quick word on where we are going with it. I think we are looking right now both at different applications and low-level primitives that we believe the system like this should provide. One of them has to predictable control. So you configure your home in a certain way. How do you know it's actually going to behave in that way? So we are developing systems that we call like fast forwarding, so you can actually look into the future how your home is going to behave. We're looking at sensor data privacy issue in the context of a particularly privacy-sensitive application we call digital neighborhood watch. So you have a bunch of cameras in your neighborhood. How do you do neighborhood watch that humans do? Can you actually digitize the entire experience while preserving privacy? And then final thing we're just beginning to think about is how we take the base of this infrastructure and turn it around into a shared infrastructure that the research community can use. Instead of individual researchers developing their own piece, imagine there's a global infrastructure at large that we call Home Lab, and you can recruit homes to develop like the work that George is doing, so everybody doesn't have to do independent recruiting, and you can independently scale. And some of the motivation here is coming from this system that got done in the networking and systems community called Planet Lab. And we'd love to see something like that happen in the home setting as well. With that, I'll end. And if you have any quick questions, I'm happy to take those. Otherwise, we'll take those in the panel.
Yeah. Great, thanks.
Yeah.
We've got 5 minutes for Ratul. Yeah.
Hi, I'm Lynn Bartram from SFU. I've actually been building sustainable homes. And I wish I'd had this 3 years ago because we built it from scratch. So my question is, you've described as sort of a home integrated with the cloud. I work closely with the energy utilities. And so one of the challenges we have is how do we bring homes on to integrate and with what levels of data with a cloud that isn't just the home itself, but with the energy utility and the whole introduction of smart meters, which has been a Pandora's box.
So I think I missed the suggestion there in your comment. So could you just repeat the question for me?
My question is, if you are looking at integrating with other clouds, if you like, things like energy utility data, both Microsoft Home, for example, and Google Power Meter went down and weren't continued, largely, I think, because they weren't informative enough or in the wrong ways. But once we start having systems like this where the data goes beyond the home, the question is what goes outside to whom, and are you looking at those questions? Because there's a huge application here in district energy management and individual energy management.
Yes, so I think the answer to that is, so we are beginning to look at that, but to make sense of the entire domain, I think we are essentially following individual examples to see what happens to the data. I think one of them that we're looking at is digital neighborhood watch, where it's more about camera data, so to speak, and we're beginning to understand what kinds of concerns people have about the camera data, given it's a very, very rich sensor, and what kind of shared sensing can happen across cameras that belong to different people. Another domain we're beginning to look into is, I think, related to insurance companies, for instance, like with security devices, and where insurance companies and homes both have an interest in knowing, okay, what kinds of security-related sensors are there? If alerts happen in your home, can you actually tie it directly back to insurance companies or monitoring agencies? The tricky bit, I think you've correctly identified, and we're trying to understand how to do all of this like in a way that both consumers of the data as well as the owners of the data, which are the users, feel comfortable with the processes. Yeah.
Another question? It doesn't seem fair for me to ask a question, so.
Patty Brennan from Wisconsin. Implicit in everything you've said is that you have to have a home that you stay in every day. and that the network is attached to the building. Is that a fair assumption? Have you thought about making that more flexible, like I could carry my home with me, or my sister could move into my house and bring her home network with me?
What does it mean for your sister to bring her home network to your
Well, I'm
home?
thinking about somebody coming home from the hospital that has to spend a week in your house for rehabilitation, or I'm thinking about mostly I'm just wondering to what extent is a unique physical space a prerequisite for the home OS?
Oh, it's not. It's not. I think it's basically, you can think of it as like it's kind of brains in the system that integrates a bunch of devices. So to make some, sorry, what?
I could carry it with me.
You could carry it with you. You could carry it with you. But at the same time, I think we'll have to see. I think there are two possible worlds there to enable that scenario. One is around guest devices. Yep. So if your sister comes into your home, like her devices of interest to her could integrate with your home hub. So both of those models are possible, or she could just bring in her own home hub. There's nothing that stops two of them from existing in the same house, like yours and your sister's. So I think from a systems perspective, I think both of those options are possible.
Okay.
Yeah.
Okay, one quick one, and then we'll flip over.
I just want to raise the issue of sort of, if you look at different countries, houses are very, very different. Mm-hmm. So cultural constraints within houses are very different. So from locking behavior, whom do you let in your house, all the way to the devices. I think we have seen this in the UBCOM community. Sort of a lot of sort of heating control in the US is completely different from most part in Europe and so on. So how do you think? Sort of, I think we have already traveled sort of with the standard software to get it sort of working around the world, and I think with the home it seems sort of a task that's nearly impossible.
So I guess I don't yet believe it's impossible. Maybe a year from now I might, like when Rob. I think some of these issues might be. Well, I believe some of these issues can be solved using the right software architectures. So it's quite possible that some applications, so for instance, like we divide the world, we see the whole software thing in terms of drivers and applications. So it's quite possible, I think drivers for the kinds of devices in the US would be different for the kinds of devices in Europe. And we see that, for instance, when, let's say, the Z-Wave standard has different frequencies, but same software will work because the software is aware of the differences, or there's a piece of hardware that's aware of the differences. But in the end, I think what it boils down to is factoring out these differences, and I believe, like through the right APIs or control points in there that's aware of the differences, they can be accounted for.
I think we should pick this.
Okay, yes, we'll take this up over lunch, which will... Okay, so we have our third speaker, so then it becomes the really exciting panel discussion, and the more provocative questions you ask our speakers, the more exciting it will be. But first, I'm delighted to introduce Dr. Nilanjan Banerjee, who's an assistant professor who just moved to the University of Maryland, Baltimore County. His research interests span renewable energy-driven systems, healthcare systems, and mobile systems, and he received an NSF Career Award in 2011 and received his PhD from the University of Massachusetts at Amherst. Thanks.
Thanks, AJ. So my talk is titled Towards Designing Sustainable Homes. If you basically look at self-sustainability in the renewable energy space, self-sustainability is usually defined by this term called net zero. So what it means is the amount of energy that you produce and you consume over a period of time is the same. So if we consider the net zero homes as the zero axis, we can potentially divide existing homes into three broad categories. At the extreme left end, you have all of these off-grid homes. These are homes that are totally driven by renewable energy, like solar, wind, or hydro. Ideally, you would think that these are net zero by definition. However, they actually use things like AC generators and propane generators, so they're slightly far from net zero. And then you have all of these intertied homes. These are grid intertied homes, which are partially driven by renewable energy. So they have a tie back to the grid, and they can buy and sell electricity to the grid. And to the extreme right end are homes like mine. So this is actually my apartment complex, where I'm totally grid tied. And the only thing that limits me is this total electricity bill that I get at the end of the month. So I only get panicky if this electricity bill is above $200, say. So for each of these homes, you can define this thing called the energy gap, which is essentially the difference in the net energy consumed by each of these houses when compared to net zero. So to give you some idea about what this energy gap might look like, here's a graph which essentially compares the per day energy consumption of a house which is totally off the grid. It's not even net zero. And a grid-only house of a similar size. So the energy budget difference lies in the order of like 2 to 3x for these two homes. So the overarching goal of my research here is to first quantify this gap and then try to understand how we can bridge this gap, whether using more energy efficient technology, through the change of usage behavior. And another thing that we want to figure out is by comparing these three types of houses, whether there are lessons that we can learn from, say, off-grid homes and maybe apply them to grid-tied homes to move them closer to self-sustainability. So as a first step towards that, we are collecting some real data. And over the last 9 months, what we have potentially done is made deployments using Home OS and collected a lot of data over a small set of houses. So when we started this project about 9 months ago, we didn't really have any idea of what the specific challenges were that people in, say, off-grid or grid-tied homes face. There are a lot of deployments out there in, say, grid-only homes from an energy perspective, but not a lot of deployments in say, these renewable energy-driven houses. So as a first step, what we did was we performed this online survey where we sent out this survey to 8 households. 4 of them were off the grid, 4 of them were grid intertied. And they were in California, Arkansas, Massachusetts, Nebraska, Hawaii, also one house from Canada. And these are all houses which are driven by some sort of renewable energy. And they also have some auxiliary power sources like diesel or propane generators. And we came up with 3 conclusions from this survey. The first conclusion being there's a need for like non-intrusive energy monitoring, visualization, and control in these houses. So one of this guy, from this particular survey, said that it would be really nice if I don't have to access my numbers by trekking up the power shed and peering at the readout for the outback, which is actually an AC generator. And one of the reasons that these guys have not used smart home automation techniques is cost. And a lot of installations that these guys do are actually very custom. So smart home meters would not actually work. Another thing that we figured out was there's actually a need for automated or semi-automated demand response systems in these houses. These people actually use very manual techniques to manage energy. For instance, they would not use a vacuum cleaner, or they would use a particular appliance only when it's sunny. The third thing that we figured out was, with respect to these renewable energy-driven homes, there are several external factors which affect energy generation. For instance, like somebody pointed out that there are mold suits due to oak trees that has caused a lot of problems in their PV panel system. Or trees surrounding their house is a big deal. So kind of armed with these insights from this online survey, we have actually designed a system over Home OS, which acts as a measurement infrastructure, visualization, as well as a control system for these homes. So the home component in our case actually is built on top of Home OS. So we use commercial off-the-shelf Z-Wave meters as well as custom meters that we have designed and collect data at a gateway. And we have written a driver for Home OS which can actually aggregate this data and send it over to a data collection app written in Home operating system. And all of this data is kind of sent off to a standard server component. And it can also receive like commands from this server component to basically control appliances. The server component is pretty standard, but one of the things that I would like to point out is we have also built a very extensive RESTful API around the server component that can be used for building pretty cool. We've already built an iPhone and an Android app and a web interface that people can go ahead and look at their energy consumption, can control appliances, even run functions like correlations, et cetera, to figure out where the bottlenecks in their homes are. And one of the things that we are working on is kind of releasing this REST-based API so that third parties can actually build apps using the data that we have collected. So kind of getting to the notion of this open platform so that people can use our data. So we have been collecting data for a year now, and we have installations in 8 homes, and we have 8 more homes which are actually lined up in the renewable space. We have collected data varying from like 700 days to about 300 days in each of these houses. And we are going to continuously collect this data for at least 4 years, which our IRB approves. So this is actually an example of an off-grid home that we have an installation in. So now what I'll do is I'll actually try to draw some insights from some of the data and the deployment that we have done in these houses. So one of the big things that we have found in these renewable energy-driven homes is the need for non-intrusive energy management. So to just motivate that, here's a graph which actually shows the energy consumption per day for our monitoring infrastructure, which is only about 800 watt-hours. In an ordinary home, this would not be a big overhead. But if you compare it with the daily energy consumption of an off-grid home, this actually accounts for about 20 to 30% of the total energy consumption. So it's a big overhead. So what we have been working on is kind of figuring out through sampling analysis what is the optimal rate at which we can sample all of these appliances so that we can duty cycle our total monitoring infrastructure. I'll not go into the details of the algorithm, but we have been using like contextual information, time of the day information, usability information to like derive a frequency spectrum of use of appliances and then duty cycle our stuff. The next thing that we have been looking into is trying to figure out this minimal set of appliances that we need to monitor. So we need to monitor appliances that people want to control, obviously. And in addition to that, find out the smaller set of appliances that would be sufficient so that we can use some sort of disaggregation analysis, which is out there in the literature, to figure out, say we only want to monitor 2 more appliances, and then we would be able to derive very accurate profiles for all the appliances in the house. So we have been using like a lot of techniques like unsupervised learning, even using signal processing techniques like matched filters to do analysis on the data that we have collected to extract this minimal set of appliances to monitor. So one of the big things about these deployments is they are very remote. I cannot fly to Hawaii to deploy this. So potentially I need a system that I can just ship out to these people, and they can just plug it in and use it. So we are going towards that. The other insight, we have gained a lot of insight in off-grid home energy management. And I'll just point out one of these insights that we have gained. One of the things that we found out was off-grid homes are not truly sustainable. In fact, about 25% of the time, these guys actually use propane or diesel generators. And these people are pretty reactive in the way they manage energy. So here's a graph which actually shows the energy consumption of the house 24 hours before the AC generator was used. And by talking to this guy and also looking at the data, it seems like when he figures out that the battery voltage is going down, he fanatically stops using appliances. Unfortunately, this reactive technique works sometimes, but in most cases, he has to use the AC generator. However, if he used more proactive techniques and was able to predict basically that he was going to use the AC generator, then potentially can use techniques like task rescheduling to prevent the use of the AC generator. So here's a graph which is basically a scatter plot of the battery voltage as a function of the energy consumption. And there are several instances where tasks are performed when the battery voltage is low. And they can be moved to times when the battery voltage is high, thus preventing the use of the generator. We have gained a lot of other insights, and we have written a paper on that. Most of the results are in there. But this is a project which is in its infancy. We have only worked on 9 months on this, and this is far from conclusion. We are trying to expand this to make a more wider and more robust monitoring infrastructure. We have faced all sorts of failures here. So we are trying to fix all of that, analyze that. Also working on this open platform where third-party developers can use our data through this API for application development. In fact, I think like the web interface, for instance, could have some social networking aspect to it, where people can be incentivized to save energy. This is not a new idea, but it could be integrated with our system. We are also using this system for home automation for people with disabilities. We have built some nanostructured sensors that can be built into your clothing, so people with paralysis can actually the gestures for people with paralysis can be detected, and we can use the same automation system to control appliances. We're also working on building a recommendation-based demand response system, which can provide you recommendations about how you can actually make your house more self-sustainable. And more than that, we are also trying to understand the similarities and differences between these three different types of houses to see if we can use lessons learned to basically make homes self-sustainable. So that would be it, I guess. Happy to take any questions. Yes.